Hi everyone, welcome to this Austmine webinar. I'm Marianne Cummings, the Director of Strategic Development here at Austmine, and I'm pleased to be your host for this webinar. Before I begin, I'd like to acknowledge I'm hosting the webinar from the lands of the Awabakal people, a coastal area south of the Hunter River in Newcastle. I pay my respects to the elders past, present and future, and also acknowledge the traditional custodians on the lands on which you are meeting today and the Aboriginal and Torres Strait Islander people in the audience today. Today's webinar is the first environmental tech talk of our ESG series, which will be running across the whole year. In previous webinars, we've explored the key trends, challenges and opportunities emerging for the mining industry and MET sector as the global focus on sustainability and ESG issues intensifies. In upcoming tech talks, we'll look at innovations solving critical environmental challenges in areas such as water management, waste and recycling, and rehabilitation and remediation. You can view all the recordings and register for the webinars via our website. For this webinar today, we have 4 fantastic tech talks from Accenture, ABB, 3ME Technology and SR Systems. These tech talks will delve into the technologies and processes that are reducing emissions, introducing renewables and managing energy consumption across the mining value chain. Our speakers today will look at the importance of integrating systems and managing data in transitioning your mine, decreasing diesel consumption, and the possibilities of battery technology and smart manufacturing processes within the supply chain. The tech talks today are pre-recorded, but we have each of the speakers online for live Q&A at the end. So throughout the webinar, you can use the Q&A button at the bottom of your screen to send through your questions anytime. You can also upvote on other audience questions, so that we can see the ones that the audience most want answered. So without further ado, I'd like us to move on to the first presentation from Eric Crozer, Mining Lead ANZ with Accenture. His presentation is on the mining puzzle, integration of the value chain and full stack data to drive sustainability.
Hi, thanks very much for the opportunity to share some ideas and thoughts that we had around what we're referring to as the missing puzzle piece around the mining puzzle. And that missing puzzle piece is really the integration of the value chain across its different elements and the data associated with that, together with the integration of the data across the technology stack, all the way from the operational technology layer straight into the enterprise layer. So mining is in a very interesting space at this point. The old saying of if you can't grow it, you need to mine it still remains true. And mining it has unfortunately been core to both the problem of a very carbon intense world that we live in, but also at the core of that solution right now. It's estimated that we'll need to mine and beneficiate 2 to 4 times the amount of battery metals and associated minerals just to reach our 2040 targets. And the pressure on mining organizations is that the expectation is there to do that whilst not just retaining or maintaining the current emissions levels that they have, but actually reducing it while increasing throughput. Now, the only way this can be done is to fundamentally think differently about that landscape and how we go about actually achieving that. And to increase production rates whilst transitioning to newer technologies, something different has to happen. And what we believe that difference is really looking at a value-driven lens to the mining processes and these organizations, and really thinking about the data and the value chain integration in a bit more of a holistic sense. A recent survey that Accenture has done with shareholders, when asked what initiatives do they see as prioritization for both the valuation of mining companies, but also being core to that transition into a carbon neutral and a carbon zero future, both emerging technologies and digital transformation was placed as the top 2 from the respondents. Now, we've been really quick to adopt certain components of emerging technologies. If you think about autonomy through our processes, a lot of the autonomous haulage systems, etc., mining was a first mover in that space. But where we have lagged behind some of our peers in the manufacturing and energy sectors, as an example, is our ability to integrate the total value chain, both from a process perspective and to a certain extent because of the discrete nature of what we do, but also secondly, the data processes and the data systems across that value chain. If we then take that value chain and we just tilt it on its head a little bit, we're also quite far behind in our integration of our operational technology into our information technology system. So the whole IT-OT conversion. And the only way to reduce our emissions and our energy dependency is to increase our efficiency by having better visibility and better interoperability across that value chain, but also using that data and using the analysis across that value chain to increase yield and increase throughput for across the mining operations. So we really are in a quite nice position, one could say, challenging, but really nice, that 1 + 1 could equal 3. And the first one is really when we start looking at the integration of that value chain. Not only do we get visibility across our energy efficiencies, our carbon consumption across the value chain, but also around the actual process efficiencies for that value chain. The second aspect is if we start looking at the integration of the operational technology and that operational data all the way through into the enterprise layer, we are able to better optimize the specific components of the value chain, but also understand how that process fits into the holistic nature of it. So we are starting to move to a bit of a manufacturing mindset from a pure play push system into how we can start thinking about a just-in-time pull system. And if you think about the current dynamics in the market with the fact that we have very good commodity prices at the moment, increased pressure on getting our throughput into the market, but also thinking about how we can do it more sustainably, that integration is very important. And then the final one to add to the 3 is really the value component that is unlocked from an organizational aspect, but also using those technologies and using those data, we start attracting a different type of skill set into the organization. Now, the decarbonization can thus be the catalyst to really start shaping mining around other things. Think about the entire integration of the value chain into customer, how we can become more adaptable and agile around the demands within the market. We are starting to compete for certain skill sets that aren't necessarily seen as or have been seen as core to mining. So the skill sets that big tech usually would attract, we are looking for data scientists, we're looking for integration experts, etc. So we need to also have a different way of how we portray ourselves into the market. And then finally, it's really about the adaptation of how we do our processes and really thinking about, again, this integrated value chain. So when we start then referring to an integrated value chain, what we are actually referring to is seeing the picture for what it is. We have been very, very good, as I mentioned earlier, to see components of that and really optimizing components of that picture. But the same as any painting that you see, is it's really if you start moving away from it and start understanding how the holistic nature of that picture looks, you actually understand where you're going to. So when we talk integration of value chain and integration of data across the stack, it's really around seeing the holistic picture for what it is, understanding what our roles are that we play within that, and by stitching all of those little missing puzzle pieces together, we will and can see the main picture. Thank you very much for that, and happy to take some questions when we get to the Q&A side.
Fantastic. Thanks, Eric. Like that elephant. If you have any questions for Eric, put them in the Q&A box at the bottom and we'll answer them at the end. Our next presentation is from Nick Greshoff, Head of Mining at ABB. Next presentation's on transitioning your mines for the future. Thanks.
So let me just go over a couple of things for you. So the first thing is let's look at actually what the equipment is, what we currently have, maybe that transition, and then what it really looks like. So if we look at the actual journey, what are the things that we have? We've got, you know, automation and digital systems, we've got trains, we've got haulage trucks, people, equipment, transport, blast hole drills, hoisting, conveyors, drag lines, even electricity generation itself. If we think about what do we currently have, and even yesterday, most of it's around diesel, right? So our haul trucks are mostly diesel, people equipment's mostly diesel, trains are mostly diesel, and in some cases they're electric as well. But a lot of times diesel is used. So the transition for the future is really looking at, okay, well, what are these hybrid solutions? What is possible today? So that would be, for example, a diesel and a plug-in for a battery type system. It could be a trolley type system with an overhead line with electric. And it could be even more recently, we've seen hydrogen being used together coupled with battery type systems. And as, of course, the technology advances and battery technology advances and power densities increase, fully electric haul trucks, as an example, might be in the next 4, 5, 6, 7 years, might be fully available in the market to be able to do that. But until then, it's that journey and that transition and what's actually possible. I do want to remind that we do look, and sometimes we negate the fact that hoisting and conveyor systems should also be looked at a way to replace diesel. And I think they're currently electric, but why can't we use those? And there's plenty of examples with mining customers that have looked and have got truck and shovel type operations where conveyors or hoist systems have benefited greatly in reducing diesel requirements, and even in cases sped up production. So we look and actually think about, well, what do we need to do, right? And how can we help? So ABB has generally a very broad portfolio. So if it's from the distribution, fully down to the operation of the equipment itself, to motors, drives, generators, controls, and digitization and mine planning. So there's a full layer there of the electrification for any mine that we have available. Importantly as well is ABB has strategic collaboration with partners. This is not just all about us. We also have to think about the haul truck manufacturers as an example, and how we can adapt an electrical type solution to their truck. So we have a lot of partnerships together with most of the OEMs, and how we can work together to electrify those trucks and electrify the pits or underground as an example. We also look at then the consultancy and the mine design. So as an example, on a greenfield mine, we might do a lot of studies for actually, can you do a trolley type assist? How is that actually, what's the payback? How can we use it? How many trucks do you need? How many trucks could you maybe save using a trolley type system? And then of course, it's the fit for purpose and tailored solutions. So we look at exactly what is the right thing for you. You know, what is your, you know, are you on the grid? Are you generating yourself? You know, what is the availability to upgrade the network? You know, those types of things. Are you trying to just put one in, or trying to change the whole fleet? And then, of course, at the very end is we got to keep this stuff running through its life cycle, and what are those services that are around that? So you look at in this slide as an example, we look across the portfolio electrical system, and as you can see from the incoming overhead lines to transformers to power factor control to any other stuff on the reticulation type systems, but then also further down to the trolley systems, battery electric vehicle, underground charging here. We've got our hoist system here. We've got vent fans over here. There's all different types of things, but not just that as well. We also need to think about how do our renewables actually plug in. And as an example, I always like to say the sun doesn't shine all the time and the wind doesn't always blow. So, you know, what are you going to do? Are you going to put in battery systems? You know, we've helped out customers recently with flywheels as an example, as a method for actual energy storage. So these are the types of things that we are able to help you with across the mine. And then, of course, couple this exactly with the digital or the automation type control, as you have to be able to manage all this power, and that's a key part. If we actually break it down into an underground mine and be a bit more specific, you can see hoist on the far left and ventilation. These are some of the major users of electricity in a mine. And if we, as an example, are going to electric underground fleet away from diesel, what would be the impact on ventilation as a great example, right? That would probably reduce as an example. So that can be a major source of electricity usage. We've got the underground chargers, for example, here you might have conveyors, etc. So how do we actually then couple this with making sure that we're not bringing 10 vehicles at one time to charge and making sure that they are spaced apart? Because 10 vehicles on an electrical network is going to be a lot different than one vehicle every 10 minutes coming to the electrical vehicle network. If we look at it from an open pit mine, the key part here is really the trolley and the trucks. So the trucks generally on an open pit are generally larger. So we're talking much more draw on the power system. So we would look here at having a trolley, like I said, directly coupled to the wheel motors, and that would then provide a faster solution for it. There is the charging systems there. Do they have batteries in them and trolley charging battery? Is it, pure trolley then with diesel? There's a lot of different designs there that is possible. Couple as well, again, with conveyor systems, shovels, drag lines. There could be skid mount power controls in the pit, as an example. There's a range of different electrical things that we can do. Again, the same thing. How do you actually control all this and ensure that it's all not coming onto the system all at once, right? So 4 trucks coming on at 4 megawatts all at once onto a system can be quite a big of a load. When we look at actually the trolley system itself in a little bit more detail, the first thing is it reduces CO2. Yes, it's electric. It's driven by the trolley lines above, and this is an example from Boliden. It's higher speed, and this is really one of the key advantages, is going up those ramps. It is a lot faster, which means that in theory you can reduce the amount of trucks if it works out that way, and also maintenance cost. It has a return on investment around 2 to 5 years, and it just depends on the makeup of what you're actually trucking, etc., and size and things. So it's a great system. We're starting to see more and more of these. This is in Boliden as an example. One of the other key things that's possible is a 600 kilowatt fast charger. We use this for a lot of the underground applications and have some pilots in Canada currently. What you see over here is the actual connector into the truck. It would raise and then engage with the truck and provide power to it. So it's a great solution that we have for fast charging, generally used in underground type solutions. So I'd like to thank you, first of all, everyone, for your time, and we look forward to ABB being able to help you for reducing your CO2 emissions. Thank you very much.
That's great. Thanks very much, Nick. Again, if you've got any questions for Nick, pop them in the Q&A box. Next up is Steve Lawn, Chief Customer Officer at 3ME Technologies, and his presentation will look at alternatives to diesel fuel. Thank you.
G'day, it's Steve Lawn here from 3ME Technology, coming to you from Newcastle, New South Wales in Australia. Before I kick off, I'd just like to thank Austmine for giving us the opportunity to speak today at the Tech Talk. It's very much appreciated, and also to those of you that are listening in, I look forward to speaking to you during the Q&A. So the intent, I guess, of this presentation is to go through a little bit of history behind 3ME Tech. I've identified 5 key issues that we've faced, and hopefully that can prompt some good discussion in the Q&A. But as you can see, the title of today's talk is "Geez, Diesel is Expensive." That's topical today, but it's not actually why it's up there. It was actually the words that were uttered in 2007 when the company first attempted a battery electrification, which at the time was an EV-me. That was, funnily enough, to help reduce fuel costs. So that kicked off about 10 years worth of R&D in the on-road passenger commercial space related to the electrification of those assets. When in 2016, the company was approached by two gentlemen in the mining industry who said, hey, got some really good experience electrifying assets. Can you now direct that towards the electrification of underground mining equipment? So that's where we find ourselves today. So for a little bit of context, I'll flip now to the company video, which will provide some more information as to where we're at today.
3ME Technology is spearheading state-of-the-art battery systems into mining, military and marine applications to enhance performance, safety and sustainability. We are a fast-growing scale-up with three spheres of technology: power solutions, mobility and digitisation. We are an electric vehicle systems and battery technology company. We are helping large vehicle manufacturers electrify their offering through scalable products and services that include batteries, software, electric vehicle kits, and systems integration. We provide high reliability, clean tech for tough industries. Our team at 3ME Technology has deep technical and operational experience across the industries we serve. I'm proud of our amazing team for getting us to where we are now, but I feel like we're just getting started. At 3ME Technology, we are powering change in support of a cleaner future. So come join us and be part of the electric vehicle revolution.
Okay, the first problem that the team faced when they directed their attention towards the electrification of mining kit was it's hard to take a battery from a passenger or on-road vehicle application and have that effectively perform in an underground mining environment. And we all know how hard these pieces of kit get treated and the environments within which they operate. We also know that beyond anything else, they need to be safe. So that's what's precipitated the last 5 years worth of R&D in the battery technology space, which has delivered the blade bulb battery system. So the blade bulb battery system is a safe, modular, scalable, remotely monitored, highly maintainable system that allows us to predict, intervene and prevent battery faults that will lead to fires, but also identify issues from a maintainability perspective and remove the need to swap out a whole pack, rather allowing us to swap out a blade, which is, I guess, a much more cost-effective effort. So to solve that problem, I guess, we've sought to make a battery, successfully made a battery that's been designed from the ground up for mining. The second problem is, how do we get that battery into a system that works in an underground mine? I guess the first piece is duty cycle analysis. So this is the cornerstone of any system design that we complete. It's constantly improving with data coming back from the field. However, it's what effectively needs to be done to decide battery size, which then feeds into power distribution and safety systems. So introducing 700 volts DC into a platform, into an underground mine, requires some safety measures, obviously, and that's a big thing that we focus on here at 3ME Tech. The third is vehicle control unit software. So how do we conduct the systems integration in a manner that allows for minimal change management, i.e. an operator can jump straight in the platform, use its existing controls, and have the platform, I guess, perform like its diesel counterpart. You can see down the bottom there the motor, so supply chain, that's probably everyone's favourite problem at the moment. Don't need to speak too much about that, but it is a key part of the systems integration effort. And then finally, it's the mechanical integration of that battery electric engine package into a platform. So we work with some really incredible OEMs that utilise their wealth of mechanical knowledge to fit a system that is battery electric into a platform that was designed to be a diesel. The third problem what do we do when the battery runs out? So the guys identified about 3 years ago that having a onboard charging solution that could tap directly into a 1,000-volt AC outlet, which is the jumbo box you see there on the left, would be a pretty cool thing. So that started what's been a 3-year development cycle with Bell Power to develop what that charger is in the middle. So that's a 1,000-volt AC inlet to 350 or 700-volt DC outlet, depending on your battery size. So that lives on the vehicle, which means that in stacks of up to 100 kilowatts, we can plug directly in from the 1,000-volt AC jumbo box, which will go through our power, through the charger, through the power distribution system into the battery and charge the battery. This allows for opportunistic charging, which we feel is the key to meeting some of these duty cycles. Fourth problem, what do you do when the battery is at end of life in the vehicle? So this battery or the blade vault architecture lends itself to quickly identifying which blades or which cells are suitable for redeployment into second life storage system, energy storage systems, or peak load shaving type arrangements. So we expect between 5 to 8 years of useful life in the battery in the vehicle, and perhaps up to 15 years worth of useful life post vehicle in the low charge discharge environment that is static energy storage. Finally, the fifth problem, how do we learn and improve? So the more data that comes in, the more we get to learn about our battery, how that performs and improve it. The more we get to learn about how the system or the battery performs in the system, how the system performs in the vehicle, and how that vehicle is utilised in the duty cycle in the mine. So the picture in the middle there is what's been termed our Battery Systems Operations Centre, or BladeNet. That is a data collection tool which allows us to take data in from the field, analyse it, and improve the product. So we're looking for partners, we're looking for OEMs that want to electrify pieces of equipment, and we're looking for miners or end users who want to trial this equipment. So we can collectively learn, generate the data, and mobilise or electrify as many mobile pieces of plant and equipment as possible. So that's the 5 key problems that we're faced, and look forward to discussing these with you over the next little bit in the Q&A. Many thanks again for the opportunity to present.
Great, thanks so much, Steve. And now, and again, I can see there's questions starting to come in, so keep those coming and we'll answer them at the end. And now on to our final presentation from Prashanth Mysore, Global Strategic Business Development Director at Dassault Systems, and his presentation, Smart Manufacturing Practices for Smart and Sustainable Mining. Thank you.
Hello everyone, and thank you for joining. And in this session, we'll be looking at how smart manufacturing and Industry 4.0 technologies can be replicated to enable mine operations to work smarter and achieve significant improvements in operational efficiency, safety and sustainability, and seamless collaboration across value network to generate sustainable business growth today and tomorrow. My name is Prashanth Mysore, and I'm a Global Strategic Business Development Director at Dassault Systems. And I'll be sharing our experiences on replicating best practices from smart manufacturing into smart mining. Let's look into how manufacturing industries are addressing challenges to achieve greater sustainability, circular manufacturing while improving productivity and safety. The first one being digitized operations. Digitalizing manufacturing is a necessary part of larger transformation to stay ahead of competition. Accelerating innovation. The pace of business keeps changing, especially during disruptions and pandemic, along with consumer demand for better, faster goods and services. The third one being overcome complexity. Mass production is being replaced with mass customization. Supply chains are more complex, margins are shrinking, and skilled employees are harder to find. The fourth one being operate globally and serve locally. Diverse production site managers must be able to control extended supply chains while serving local customer needs. Driving operational excellence is an important trend as well. Competition and consumer demand put relentless pressure on operational performance. Manufacturers need resources and technology to achieve continuous improvement and to achieve sustainability as well. Now let's see how these technologies, which has shaped up manufacturing, is being replicated into mining practices to achieve sustainability and operational excellence. Industry 4.0 or Mining 4.0 with technologies listed here are crucial for future of mining, be it simulation, virtual experience, IoT, sensor-driven manufacturing processes, low emission technologies, autonomous guided vehicles, and data mining or contextualization of data from various sources are becoming increasingly crucial for smart mining processes. Now I'd like to show 5 experiences which could be easily replicated from manufacturing industries to smart manufacturing, and I'll be showing some real-life examples. What you're seeing here is a manufacturing operation management practices from aerospace and defense, which is largely being used for achieving greater productivity and sustainability. This is a manufacturing operation management solution providing digital technologies for processes, performance management, visibility across all operations, magnifying the impact of operational improvements across the whole enterprise. This is a unified application which has business processes like production dispatch board or production management, quality management, warehouse management, production intelligence pack, and even integration for IoT sensors to achieve greater manufacturing flexibility. As I said, we can leverage best practices from the aerospace and defense industries to bring in value to mining companies as a unified application with a simple web and mobile-enabled interface, leveraging a single data repository. This is all the requirements of mining companies for their digital transformation journey. The solution includes various business processes like production tracking, material balancing, stockpile management, and production execution management and decision support within the value chain. And this is all based on ISA 95 architecture, which is international standard for automation to achieve Mining 4.0 as a business process. Looking at our second experience, which is lean work management. A general tendency in mining are always ad hoc working method, which is not aligned with lean philosophy. In this case, we can establish a day in life of a mine planner, mine manager, and even workers within this lean management application. As you see here, this is a modern interactive environment, closely emulates the simplest of meeting tools, a whiteboard, a marker, and a sticky note. The objective here is to replicate natural interactions and allow anyone to engage productively. You can also see how easy it is to include digital content like geology data and even operational data to bring in manual meetings into platform and the best use of digital technology here. Cross-functional teams can work together efficiently in lean mode to solve strategic issues like safety, production delays, catch-up plans. In fact, lean principles can be applied to all mining processes to achieve sustainability and allowing the team to engage more efficiently. And this is one of the lean tools which we've been working with multiple mining companies to achieve resource optimization. Looking at experience 3, how robotics and automation can be leveraged into mining practices. Robotics and automation has been in manufacturing for a few decades now, and there are continuous improvements happening in robotics applications in manufacturing. Replicating the same, especially for underground mining to improve safety and operational efficiency through simulation and execution management, including development of programs, virtual programs, and validating PLC is a greater value for mining applications replicating best practices here. With regards to manufacturing practices, that is manufacturing simulation to achieve some of the mining simulation practices here, discrete event simulation has been used in manufacturing for throughput analysis and for resource optimization as well, by identifying bottleneck areas and congestion areas in the production plant and to optimize resource utilization and the material flow. Similarly, in modern mining operations, maximizing productivity by effective decision making is crucial and essential. Discrete event simulation is used to conduct what-if analysis, supporting mining engineers and management in enhancing decision management and decision-making support. The concept of virtual twins to create the unified data, which includes bringing in geology data, mine planning and scheduling, ERP information, fleet management into business process management based application architecture, which can easily support frequent changes to business processes, which is a key requirement that has become increasingly important within various industries to improve responsiveness to change in market conditions and supply chain conditions as well. And as you're seeing here, there is a good contextualization of data coming from 3D, which is geological data, and it is getting contextualized with data coming from various data sources like sensors and various machines, and contextualize the data, historize the data, and based on this historized data, you can do the predictive management of various processes. Coming to experience number 5, which is value network optimization with scheduling, manpower, and supply chain optimization to achieve sustainability in mind. Meeting the mine industry's demand for complete mine-to-port solution to provide visibility and integration from production planning and operational performance, manpower requirements at the mine, and all the way through to stockpile and port management, even the movement of logistics materials via port, rail, and shipping, align with decisions made by their logistics colleagues. There's one integrated end-to-end solution for mine-to-port management with scheduling optimization. So to conclude here, you have seen how smart manufacturing practices can be leveraged to smart mining to achieve sustainable innovation, value network optimization, and all importantly, to create workforce of the future with latest technologies like virtual reality and augmented reality to make the workplace future-proof. I hope you enjoyed the presentation. Thank you for joining us today. Stay safe. Thank you.
It's great. Thanks, Prashant. It's now time for Q&A. So add your questions for Prashant into the box there. I'll start off with a question from Sheena. It's for you, Nick, from ABB. Nick, what transition options are available for hydrogen?
Yes, interesting question. Obviously, hydrogen is still somewhat fairly new in the, well, it's not new, it's been around for a long time, but using on a mass scale and on a mobile scale is somewhat new. So I think there's two sides. First of all is changing the technology to be able to actually use hydrogen to either power directly. And I think if you've looked on LinkedIn and in the news, there's been some references to what Anglo American has done over in Africa with a hydrogen truck. Also, I think, you know, FMG has done examples of it as well. So there's a lot of work being done on actually using hydrogen to drive a truck and then couple that with either batteries, etc. On the other side, there's also work being done on using hydrogen to generate electricity for a mine. So a lot of gas turbines, as an example, can run hydrogen or a mix of hydrogen in them. Probably more the bigger question is actually the generation or creation of hydrogen. And I think that's where there's a lot of work in Australia that's been happening. We see that there's investments happening up in Gladstone. You know, there's talks around Australia. I think every state has some form of hydrogen project, because if we're going to make that transition over to hydrogen, we're going to have to be able to have the production to utilize it on a mass scale. And that is that's the challenge that I see in the next 5 years, is actually being able to create the demand that's going to be required, or the supply for the demand that's going to be required.
Great, thanks, Nick. Next question's from Grant. It's for Eric at Accenture. How can organisations communicate the value chain integration approach successfully to the site teams and operators who often struggle to see the bigger picture while they're doing their day-to-day tasks?
Yeah, it's a really good question, and I think it starts with that old adage that says, "Show me what you measure me on, and I'll show you what's important to me." So it's firstly around how do we measure folks, and you know, if we continuously measure the discrete components of our value chain, i.e., you measure the shift in the mining guys on run of mine, or you know, volume at stockpile or tons at stockpile, that's the behavior you'll drive. The second component is it's still interesting that we have a connected virtual world outside of mining, and then we expect our employees when they come there to sort of go back to an analog space. So really giving them the tools and designing the tools in a way that it's firstly easily usable, that user interface is something that's intuitive to them. And you know, I've always make the point that nobody ever taught my kid how to use my iPhone, but at 4 he could unlock it and call people. So it really needs to be intuitive. And I think then the third component to that is when we do the design of those value chains, that we actually bring in, and that's where analytics and some of the stuff that the folks from Dassault mentioned, where you bring the analytics in to show what that decision's effect would be on the value chain, and then also start bringing the data across the value chain into that operator, superintendent, etc., to give them a bit of guidance, and we call it sort of augmenting their decision making with that technology.
Great, thanks, Eric. Steve, a question for you, 3ME. How far along the journey are we for large-scale electrification in open pit mining, and will this be possible?
So I've got Marty Kime here too, our COO. So I'll kick off by selling the dream, and then Marty will add a little bit of realism to what I say. But I guess the short answer to that is, I think a lot of the work that's come out of the Charge On Challenge is that, you know, I think it is possible, and I think that what's especially from the I guess a number of mining companies have approached us directly with regards to electrifying or not electrifying necessarily, but converting a haul truck to battery electric base to, I guess, start that journey off or take the first steps to I guess assess what is possible in the real world. I think you know, a combination of fast charging, trolley assist, dynamic charging, a lot of the stuff that Nick spoke about previously will get us a long way there. And then I think Marty and I were just discussing it, but the caveat that he quite rightly put on that is the, I guess, the evolution of cell chemistry and how quickly energy densities do increase in that space to see the I guess a full battery electric solution rolled out across all cycles. But Marty, got anything to add to that?
No, you smashed it.
All right, cheers. That's the answer.
Thanks, Steve and Marty. Next question for Prashant. What are the challenges or points of resistance when you're seeking to adopt or adapt technologies from manufacturing into the mining industry?
So, you know, there are always challenges in adopting technologies, right? What we've been seeing, there are a lot of silos of technologies. You know, I want to put it in a funny way. When I walk into a mining company, there are like a museum of software. You know, they would have bought multiple technologies in the shelf to solve multiple business processes. The idea is to actually integrate all of those technologies in a platform kind of a concept. And there has to be a journey. You know, we have established a well-established journey called value engagement to really understand the pain points in their existing processes and technologies, and achieve stepwise incremental business value articulation there.
Thank you. And we've got time for one more question. This one's for you, Nick. How can SMEs with innovative energy solutions partner or integrate with ABB solutions to drive the decarbonisation journey?
Yep. I guess the first thing is you know, we'd have to be clear exactly what exactly they're looking for and what their solution is. The short answer there is probably reach out to myself directly, and I can help you, connect you to people, etc., and see if it's what we can do and work together. At the end of the day, ABB has a wide range of products and solutions to help the market. And as I stated in my presentations, you know, we partner together with a lot of OEMs to help, put electric motors inside trucks, if it's to put the variable speed drives or controllers, power controllers or batteries or whatever it might be. Or it could be a whole trolley type assist solution to work with some of the mining truck OEMs. So the answer there is we're always happy to look and see who we can work with, obviously. And the best thing probably to do would be to reach out to myself, and I can help you and direct you to the right people.
Great, thanks for that. That's all we have time for in the audience Q&A today. It's been, I'm sure you'll agree, it's been a really informative and interesting session. And I'd like to give a huge thank you to our presenters, Eric, Nick, Steve and Prashant, for their time and their insights today. Before we go, you can see there the other environment, the Tech Talks in the environment part of the ESG series that are coming up. You can book those via the Austmine website. That's all we have time for today. So thank you very much for attending. We look forward to welcoming you to the next Austmine webinar. Enjoy the rest of your day. Thank you.
Thanks, Marianne. Thanks everyone for tuning in.
Thank you, everyone.